Hello and welcome at the FinetLink channel. For those who are new at this channel, I invite you to subscribe to this channel, and for those who are part of the channel, welcome back. So we are configuring the static roles for the IPv4 and IPv6 network. The first material, we describe the command syntax for static routes, and we configured the static routes for the IPv4 and IPv6 network. So in the second material, we will configure IPv4 and IPv6 default static routes. We will configure a floating static route to provide a backup connection. And lastly, we will configure IPv4 and IPv6 static host routes that direct traffic to a specific host. So without any further information, let's go and configure the IP default static routes. So as we show you how to configure a default route for the IPv4 and IPv6 network, we will also explain the situation in which a default route is a good choice. A default route is a static route that matches all the packets. Instead of routers storing routes for all of the networks in the internet, they can store a single default route to represent any network that is not in the routing table. Routers commonly use default routes that are either configured locally or learned from other routers using a dynamic routing protocol. A default route does not require any far left bits to match between the default route and the destination IP address. A default route is used when no other routes in the routing table match the destination IP address of the packet. In other words, if a more specific match does not exist, then the default route is used as the gateway of the last resource. Default static routes are commonly used when connecting an edge router to a service provider network or a stub router, which is a router that only one upstream neighbor router. And here it is shown this scenario of the default static route. The common syntax for the IPv4 network for the default static route is similar to any other IPv4 static route, except that the network address now will be the whole octet as 0 and even the subnet mask will be as 0. By doing that, it means that this route will match any network address. So the basic command is as it is shown here in this figure. So when you configure the default static route, we start with the command IP route and followed by the network address and the subnet mask as all 0, followed by the IP address or the exit interface, or as we know, the fully configured with both included. And as for the IPv6 route, it is similar to any IPv6 static route, except that the prefix length here would be as 0, which means will match all the routes. So if we show the command syntax, it will be like start with IPv6 route followed by /0 that and the IPv6 address of the next hop or the exit interface or the combination of both. So let's go and configure an IP default static route in a network. So here we will have a network, and in this network, router 1 could be configured with 3 static routes, one to reach each of the remote network in the example topology. However, router 1 is a stub router because it is only connected to router 2. Therefore, it will be more efficient to configure a single default static route. And here we have an example that shows how to configure IPv4 default static route on the router 1. And with this configuration, we show that any packets that not match in more specific route entries are forwarded to router 2 at the interface with the IP address 172.16.2.2, which is the interface serial 010 of router 2. And same, even for IPv6 default static route configured in the router 1 will be the same. And it shows that all the packets not matching more specific IPv route entries are forwarded to the router 2 at the IP address of the serial 010 of the router 2. And as always, after every configuration, the next step is to verify the configurations that are done in the network. And in this case, we have to verify the default static route configured in the router 1. So to do that, we go in our router and in the privilege mode, and then by using the command show IP route static, we have the output from router 1 that will display the contents of the static routes in the routing table. We can see that with the asterisk next to the route code that shows an S, it means that this displays the static route that is indicated as a default route candidate, which now it means that it is selected as gateway of the last resort. And same will be even for the IPv6. So by using the show IPv6 route static, we can see that it is listed the candidate default route, which is selected as the gateway of the last resort. We can see that the static default route configured use the prefix /0 mask for, use the subnet mask /0 for the IPv4 default route and the prefix /0 for IPv6 default routes. We have to remember that the IPv4 subnet mask and IPv6 prefix line in a routing table determines how many bits must match between the destination IP address of the packet and the route in the routing table. And by using the subnet mask 0 and the prefix 0, we indicate that none of the bits are required to match. As long as more specific match does not exist, the default static route matches all the packets. And after that, we have a syntax checker. So let's see at the syntax checker, and we will configure the static route on the router 3 to reach all the remote networks. So here, router 3 is the same as router 1 is a stub network because it's connected only with one router, which is router 2 at the interface serial 011. So here, same as the router 1, we will configure the default static route to reach all the remote networks, which means by using the command IP route with the network all the bit 0 and subnet mask all the bit 0 and followed with the next hop, which is the IP address of the serial 011 at the router 2. Same with the IPv6 address, and then we use the show IP route for the IPv4 network and show IPv6 route static for the IPv6 IPv6 network, and by this we see that we will configure the default static route even at the router 3. After we are done with the default static route, what we will do is configure a floating static route. First of all, we have to explain what is a floating static route. So another type of the static route, as we mentioned even in the first material, is a floating static route, where the floating static routes are static routes that are used to provide a backup path to a primary static or dynamic route in the event of a link failure. The floating static route is only used when the primary route is not available. And to accomplish this, the floating static route is configured with a higher administrative distance than the primary route. The administrative distance represents the truthworthiness of a route. If multiple paths to the destination exist, the router will choose the path with the lowest administrative distance. For example, let's assume that an administrator wants to create a floating static route as a backup of enhanced interior gateway routing protocol learned route. The floating static route must be configured with a higher administrative distance than enhanced interior gateway routing protocol, which this protocol has an administrative distance as 90. So if a floating static route is configured with an administrative distance of 95, the dynamic route learned through this protocol is preferred to the floating static route. And if the enhanced interior gateway routing protocol learned route is lost, then the floating static route is used on its place. Here we have a figure, and in this figure we have the branch router typically forwards all the traffic to the headquarter router over the private WAN link. And in this example, the routers exchange routing information by using the enhanced interior gateway routing protocol. And then a floating static route with an administrative distance as 91 or higher could be configured to serve as a backup route. If the private WAN link fails and the enhanced interior gateway routing protocol route disappears from the routing table, then the router will select the floating static route as the best path to reach the headquarter line. By default, static routes have an administrative distance of 1, making them preferable to routes learned from dynamic routing protocol. For example, the administrative distance of some common interior gateway dynamic routing protocol are, as I said, for enhanced interior gateway routing protocol is 90, open short path first is 110, and intermediate system to intermediate system is 115. The administrative distance of a static route can be increased to make the route less desirable than that of another static route or a route learned through a dynamic routing protocol. In this way, the static route floats. It's not used when the route with a better administrative distance is active. However, if the preferred route is lost, the floating static route can take over and the traffic can be sent through this alternate route. So let's go and configure these floating static routes for the IPv4 and IPv6 network. When we configure the IP floating static routes, we will configure them by using the distance argument to specify an administrative distance. If no administrative distance is configured, then the default value will be as 1. Let's refer to this topology and we will configure the IP route and IPv6 route commands for the router 1. And in this scenario, it is preferred as the default route for the router 1 or the router 2, and the connection that is with the router 3 should be used only as a backup. And here are listed the command that we will configure the default static route, which point the network to the router 2. And because no administrative distance is configured, the default value will be 1 for the static routes. And router 1 will be also configured with the IPv4 and IPv6 floating static default routes pointing to the router 3 with an administrative distance as 5, as you can see. By doing this, we are configuring the default static route pointing to router 2, and in case the link fails, then the traffic will go through router 3 to reach the remote network, and this will be the backup line. And since we want this to be a backup line, when we configure the floating static default route to point to router 3, we will add an administrative distance bigger than 1, and in this case we choose it as 5. And therefore the route float and is not presented in the routing table unless the preferred route fails. So by using the command show IP route and show IPv6 route, we verify that the default route in router 2 is installed in the routing table for both networks. But you can see that the IPv4 floating static route to router 3 is not presented in the routing table. But when you use show run include the IPv6 route, we can verify that the both static default routes are configured for the network IPv6. So to see and if we did a good configuration and if the preferred route to reach the remote network fails and if it will activate the backup line, which means the floating static route, we have to do a test, which means that here in this figure, we will suppose that the router 2 will fail. To do this in this example, what we will do is that we will go to the router 2 and we will go to the interface serial 010. By doing so, we will go to this interface and we will shut this interface down. And then we will go to the other interface of the router 2, and even that interface will shut it down by using the command shut. Now we see that router 1 automatically generates messages indicating that the serial interface router 2 is down, as you can see. And now a look at the IP routing table of the router 1. We will verify that the floating static default routes are now installed as the default route on the pointing to the router 3 as the next hop router. So if we go now to the router 1 and use the command show IP route static, begin with the gateway, as you can see, we are able to see the static route. So the gateway, the last resort, is by going through the router 3 at the interface serial 010 with the IP address 10.10.10.2. By doing that, we can see that if the link fails for the network router 1 to send the packets to the remote network through router 2, then he will use his backup line to send them through the router 3. But as soon as the lines back up, which means that the router 2 will be active, the default route will be used as the route that sends the packets through the router 2, which means that he will get his function as the preferred route to send the packets to the remote network. Even for the floating static route, we will go and do a syntax checker where we will go and the router 3, we will configure the floating static route. First, we will configure the default static route on router 1 to reach the remote network through router 2 at the IP address 192.168.1.2, which is the IP address of the next hop, the interface of serial 011 to the router 2. And after that, we will configure the backup route, which will be the floating static route at the to reach the remote network through the router 1. So here in this syntax checker, we will configure and verify the floating static route based on the specification requirements that are in this syntax checker. So we will go to the router 3 and we will configure the default static route, which will point the network to the router 2 as the next hop address as 192.168.1.2, which is the IP address of the serial 011 interface of the router 2. And then we will configure the floating static route, which will point the network to the router 3, the traffic to the router 3 at the next hop, the IP address for the router 1 at the interface serial 0111. And we will choose a higher administrative distance for the floating static route, which will be 5, and then we will go and configure even the IPv6 floating route and default static route for the router 3. So the steps are shown here. And remember that when we configure the IP route in IPv4, it will be the network address and the subnet mask all bits as 0, and here and even in the IPv6 will be the same. The prefix line should be 0. The subnet mask, remember that the subnet mask 0 and the prefix line 0 means that there will be no matching at the routing table and the traffic will go through that default route to reach the other networks. Host route is an IPv4 address with a 32-bit mask or an IPv6 address with 128-bit mask. There are 3 ways a host route can be added to the routing table. The first is by automatically installed when an IP address is configured on the router. The second one is configured as a static host route. And the third one will be a host route automatically obtained through the other method. Let's see automatically installed host route. A Cisco iOS automatically installs a host route, also known as a local host route, when an interface address is configured on the router. A host route allows for a more efficient process for packets that are direct to the router itself, rather than packet forwarding. This is an addition to the connected route, designated with the code C in the routing table for the network address of the interface. When an active interface on a router is configured with an IP address, a local host route is automatically added to the routing table. The local routes are marked with the code L in the output of the routing table. The IP address assigned to the branch serial 010 interface are 198.5.100.1/30 and the IPv6 interface 2001 DB8 ACAD 238/64. The local routes for interface are installed by iOS in the IPv4 and IPv6 routing table, as it is shown here in this example. Remember that the connected route are with code C and the local route are with code F. A host route can be a manually configured static route to direct traffic to a specific destination device, such as server shown in this figure. The static route uses a destination IP address and the subnet mask as /32 for the IPv4 host route and the prefix length as /128 for IPv6 host routes, which mean all the bits will be 1. So here let's configure a static host route on a branch router to access the server. By doing so, we use the iproute command. We add the address of the server, which is 209.165.200.238, followed by the subnet mask as all bits 1, which means each octet will be 255. And then it will, in this case, is followed by the next hop, which is the IP address of the internet service provider 192.51.100.2, or as we configure for the IPv6 network, at the branch router, at the configuration mode, we add IPv6 route, followed by the IPv6 address of the server, slash the prefix length as 128, followed by the next hop, which is the IP address of the internet service provider connect to the interface connected with our branch router. And as always, after each configuration, we can review both IPv4 and IPv6 route table to verify that the routes are active. So, by using for the IPv4 network show IP route begin with a gateway, we are able to see that the static route is added, the static host route. And with using the show IPv6 route, we will be able to see that even for the IPv6 network. But remember that we can configure IPv6 static host routes with the link local next hop, because for IPv6 static routes, the next hop address can be the link local address of the adjacent router. However, you must specify an interface type and an interface number when using a link local address as the next hop, as it is shown in this example. First, the original IPv static host route is removed by using the command no IPv6 route followed with the information. And then we fully specified route configured with the IPv6 address of the server and the IPv6 link local address of the internet service provider. To do so, we go to IPv6 route, then followed with the IP of the server slash the prefix as 128, followed by the exit interface, which is the serial 010 for the branch, and then the link local address of the internet service provider, which is FE802. And then by using the show IPv6 route, we are able to see now the new static route that is added to the router. And even for the static host route configuration, we have a syntax checker. And here in this syntax checker, we will configure the static host route based on the requirement of the static set. But first of all, it looks like we have to display the routing table on all the both the branches for both networks, IPv4 and IPv6. And so this is the routing table of the IPv4 network, and then we will show which we can see we have only the direct connected network and the local network listed for both IPv4 and IPv6. Now we have to go in the global configuration mode and we have to configure the host address for the branch route to reach the server, but this time by using the exit interface, not the next hop. So we go to the global configuration mode, and then we use the IP route followed with the IP of the server, the subnet mask, and the exit interface of the branch router. For IPv6, same. The IP address of the server followed with the prefix length and then the serial interface, the exit interface of the branch router. And after that, we use the show IP route, and then we can see that the static host route that we just configured is added to the routing table for both the network IPv4 and IPv6 network. So thank you for being with us at the channel, and if you like the video, share it with your friends, and see you to the next session.